Moving on to the third section, this section is talking about the hydrologic cycle, which is the second cycle that we are paying a deep attention into it. First is the rack cycle, and the second will be a hydrologic cycle. As you see, we see the main process here: evaporation, precipitation, and runoff. So we'll talk about each in detail in the following sections. We need to know that water moves through the hydrosphere's many reservoirs by evaporating, condensing into clouds, and falling as a precipitation. Once it reaches the ground, rain can either soak in, we call it infiltration, and also running water is the most important element here that sculpting Earth's landscapes. It will form variety in landscape. So we'll talk about these formations in the next section. So I want you to watch this video. It's only 3 minutes, but give you a lot of details in what we are going to study in this chapter. Sorry. So let's listen to it.
Hello there, this is Callan Bentley. Welcome back for another Smart Figure. After watching this video, you should be able to describe the basic functioning of the water cycle and describe what proportion of the world's water is found in rivers. Here's an example of a river. It's flowing through a relatively arid region of the world. Rivers like this are the lifeblood of communities that live in these dry parts of the world, and they're also the most important agent for sculpting the landscape. But river water is actually a very small percentage of the total water in the world. Most of the water in the world is found in the oceans, about 96.5% of all the water. A small additional component is found in saline lakes and saline groundwater. And of all the water in the world, only about 2.5% is fresh water. Now we want to zoom in on that 2.5% and examine it closer up. Of the 2.5% of the world's water that is freshwater, about 68% of that is present in glaciers or ice sheets. Of the part that's not frozen, we see groundwater, and then there's about 1.3% of the total that is surface water and other fresh water. And once again, we want to zoom in on that water and take a look at what it is. And you can see that actually, even though it's not part of glacial ice, there's still snow and ice is a large part of that, around 73%. Around 20% is in lakes. All right, so even though lakes are really prominent on our maps, they're only 20% of 1.3% of 2.5%. Of the part that's not snow and ice and the part that's not lakes, we've got soil moisture, swamp water, the water that's in our atmosphere, the water that's in living organisms, and then the only thing left, the remaining paltry 0.46%, is present in rivers. So rivers are a tiny proportion of a tiny proportion of a tiny proportion of the world's water, yet they are quite important. Rivers are part of the water cycle. The water cycle is driven by heat energy that's provided by the sun, and that sun energy warms up water that evaporates. It evaporates and enters the air. As it is in the air, it can end up settling out again in the form of precipitation. This is either rain or sleet or snow. And as it falls down onto the land, basically that water has three options. Option number one is that it can evaporate again and go back into the clouds. Option number two is it can soak into the soil and go underground, and we call that infiltration. And option number three is it doesn't re-evaporate, it doesn't soak into the ground, and instead it simply runs off over the surface of the earth. And that, of course, would be the water that ends up in rivers. Okay, is this an example of evaporation, infiltration, or runoff? Well, hopefully you identified this as a cave, and you know that caves are underground. Caves are carved by groundwater, and so the water would have had to have infiltrated in order to produce this cave, not run off or re-evaporated. Good job. Thanks very much for your attention. This has been another Smart Figure.